Hello everybody. So today what I realized for this video is I haven't done a mechanism question yet. So we are going to do a mechanism question. This is actually a question that was taken from a past organic chemistry exam here at UTSC, University of Toronto Scarborough, if you don't know that. It was the 2014 summer exam. So the question basically asked to solve this mechanism. Now, the reason why I chose this mechanism is because it's a little bit challenging, and in the course that I'm TAing this summer, we just went over imine hydrolysis, so that's what we're going to do today. So usually what you see is the reverse reaction in your course, right? Usually what you see is the uh, conversion of an aldehyde or a ketone into an imine or an enamine. However, we're going the other way around in this case because that reaction is in equilibrium, right? So it's not the usual mechanism that you see, but we're going to go through it. So first, let me just go to my draw tools and choose that. Okay, so the first thing to realize about this reaction is even though the way the question was written, it's just one arrow going one direction, the reaction happens in equilibrium, right? You can control it by controlling the pH of your solution. So the first part of this is, and this is my, so what I'm going to teach you guys is kind of the strategy that I have for basically solving any mechanism question. Now, this doesn't work 100% of the time, but it's a good way if you are kind of confused and you've seen the mechanism before. So, what you want to identify in each step of the mechanism is what is the most nucleophilic atom in that step, and what is the most electrophilic atom. So in this case, because we have HCl and H2O that forms H3O plus, we know that already. It's really easy to identify the nucleophile and the electrophile, right? The only thing that could attack really here is actually the electrons on the nitrogen, and the only thing that could accept the electrons is the proton, right? So that's what we're going to do. We're going to draw an arrow there, and we're going to take that there. So what we end up with is something that is similar to the first compound that we started with, except the nitrogen is protonated and you have the positive charge here, right? So that's the first step. So I'm going to write kind of the tips here. Step one, what is the most nucleophilic atom? Sorry, really had bad handwriting. What is the most nucleophilic atom, and what is the most electrophilic atom, right? The other thing to realize about this specific mechanism is that the arrows that I'm drawing go towards, actually they don't, but they should be, it should be an equilibrium type of arrow, right? So it should be going towards both directions, right? So we end up with this, and we kind of have this, although the H2O, don't worry about the H2O and the H3O plus, they're kind of interchangeable because we're starting with a bulk solution of acid, so there's a lot of H3O pluses in that solution, and there's a lot of H2O. So what is next? Well, the next thing is, let's do the same thing we did in the first step. Let's identify the most nucleophilic and the most electrophilic component, right? So what is the most electrophilic, well, actually that might be hard. What is the most nucleophilic atom in this step? Well, the only thing that has electrons to give away is actually the oxygen, right? So that is the most nucleophilic atom. What is the most electrophilic atom? Well, if you focus here, this nitrogen is usually a little bit more electronegative than the carbons, but it has a positive charge, so it's kind of electron deficient because it's sharing some of its electrons with the hydrogen, right? So this nitrogen is pulling electron density towards it, which makes this carbon here very positive, or partially positive. So the electrons here are actually, I'm going to actually just delete that partially positive because it's going to get in the way of my arrow. The electrons on the oxygen are going to attack that carbon, and what you're going to end up with is something like this. Oh, and the electrons in this pi bond are going to go towards the nitrogen, because you can't have a carbon with more than 4 bonds, right? So you're going to end up with this, and there's a positive charge on the oxygen because it has 3 bonds, and you have the nitrogen with the proton on it, right? So now what's next? Well, now something has to pick up these hydrogens. Now some people, what they like to do is they like to just, because eventually this nitrogen is going to gain another proton, if you know the mechanism from before. This nitrogen, some people like to do it like that. So some people like to just do the entire proton transfer in one step, where this nitrogen attacks this proton and gains it, and gains the positive charge, and this oxygen loses that positive charge. I don't like to do that. What I like to do is actually just work with what my solvent is, which is water, right? Because we have a lot of this guy. So this water is going to basically pick up one of the protons. It could also actually not just be the water. It could also be just another one of these imines picking up the protons, so that it becomes like this and it goes through the mechanism again. But we're just going to use water here for simplicity. So what you end up with is something really simple. It's just a deprotonated version of what we started with, right? So, and you got the H3O plus that was formed from that, right? Okay, so now what happens? Well, I'm actually going to just delete this H3O plus for 1 second, and I'm going to expand it a little bit because we're going to use it. So this nitrogen now is actually pretty basic, and so what it could do is it could pick up a proton from anything that's slightly acidic in solution, right? So this nitrogen is going to pick this up, and you're going to end up with NH2 plus, right? You have a positive charge on that nitrogen now, and you have the OH, right? Now what's going to happen? Well, let's identify, but okay, by the way, if we go back just one step here, what was the most nucleophilic atom here? Well, between the nitrogen and the oxygen, we know that the nitrogen is more electropositive than the oxygen, therefore it would like to give away its protons a lot more, and the oxygen likes to hold on to its protons a lot more, right? So that's why this nitrogen is going to attack instead of the oxygen. Another hint is that if the oxygen attacks the proton, you're just going to end up with what you started with, right? That is wrong for that. You can figure out is wrong, right? So now what we have this, right? So what is now the most nucleophilic thing in this step? Well, you have the oxygen with the proton on it, and it's the only thing that could give away electrons, because all of the electrons that are with the nitrogen are occupied in bonds, right? So these electrons will come down to form a double bond, and this bond between the nitrogen and the carbon is going to break. Now another pro tip is, remember, let me just go back to that thing. Carbons cannot have more than 4 bonds, right? So let's do this. Tip number 2, carbons cannot, that's bad handwriting. I really need to take like a handwriting course. Cannot have greater than 4 bonds, right? Because it is in period number 2 and it cannot expand its octet. If it was an element in period number 3, it would be different, but that is what we have to live with, right? So, what do we end up with now? Well, it's actually going to be, we're getting closer to what we started with, right? You have this carbonyl now that formed, which has the positive charge on it because it's still protonated, and this NH2 now broke. Now what's the next pro tip? Well, the next pro tip is actually kind of complex, but it's a good way of checking your work, right? Whenever you break a carbon bond with something else, either a carbon-carbon bond or a carbon and a heteroatom, or whenever you form a carbon-carbon bond, What I want you guys to do is always count the number of carbons before you did that and after you did that, right? So where's my pen? Count number of carbons if break/form bond. I need to get better at writing, right? So let's see how many carbons we started with, right? So if you look at my, I'll change the color here, but if you look at my cursor here, so we have 1 carbon here, 2 carbon here, 3 carbon here, 4 carbon here, 5 carbon here, 6 carbon here, 7 carbon, 8 carbons, and 9 carbons, right? How much do we have here? Well, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 9 before and 9 after. So the number of carbons didn't change. That's always a good sign, right? Now this is actually a really important tip, especially when you're forming carbon-carbon bonds. It's really easy to add carbons without noticing, or when breaking carbon-carbon bonds. I always see this whenever I'm grading an organic chemistry exam or quiz. It's one of the most common mistakes that I see, and it's really easily avoidable, right? So that is one tip that I have for you guys, right? Now we just want to, so if we look at what our product is here, so this is our product, right? So we're really close to that. All we need to do is deprotonate this carbonyl and protonate the NH2, right? So what would deprotonate the carbonyl is probably going to be water in solution, or it could be that imine that we started with, or it could be this amine here, but I don't like to do intramolecular proton exchanges, so we're gonna go with that. And you have the NH2 here, and you have the carbonyl here, and you form that H3O plus, right? Now, one last step. Remember, the majority of our solvent is still pretty acidic, right? So if our solvent is acidic and we have a base, obviously that base is going to pick up some protons, right? 1 proton, right? So because acid-base reaction, right? We learned that in first year. So you have an NH3 plus, right? And that is also a very important thing. Always check. So I'm going to write tip number 4 underneath here. Always check if starting solution is acidic / basic, and how that will affect the product, right? Because in this case, we started with acidic solution and our product had a basic functional group, so it would pick up the proton from the acidic solution. How that will affect the product. Now, I do have one more tip here. It's the last tip, and it's a really good tip. Usually, it's not always the case, but usually if you have a reaction like this, especially imine-enamine reactions that are happening in acidic solutions, you should never see a negative charge formed in your mechanism, right? So if we go through the mechanism one by one, you'll notice, right, there's no negative charge at all, right? And the same is true if you're in a basic solution. If you're in a basic solution, you should never see a positive charge, right? So tip number 5, if in acidic solution, and this is not for all reactions, this is not a blatant rule, so don't take it that way. It's just the general rule, just to keep your eyes aware. But you should note that if there is a reaction, a mechanism where it's an acidic or basic solution and you see the opposite charge, so if it's an acidic solution and you see a negative, and if it's a basic solution and you see a positive, you should note those types of reactions and keep it in your head, because those are kind of exceptions to this rule, right? So if an acidic solution, never see positive charge, sorry, really bad handwriting, charge If in basic, never see negative. Now I'm saying never, it's not really never. Sometimes you will see this happen. This is not a rule that applies to 100% of all organic reactions. So, but usually you don't see the positive and negative charge in acidic, in basic and acidic solution respectively, right? Okay, so that is the end of this video. I hope this helped. I hope the tips helped. Please let me know if you liked the video, and if you do, please hit the thumbs up and subscribe. And if you have any suggestions about the video, please comment or email me at, I'll write my email here again, but it's also in the description box, chemistrytutor at gmail.com, right? And if you have any questions that you want me to solve specifically on this channel, please email that question to me, and I'll solve it in my upcoming video. By the way, I also started I'm gonna start uploading videos regularly on Sundays and Tuesdays. I was told that the best time to like send anything is on a Tuesday morning, because then most people will see it statistically. So we'll try that out. Yeah, so there should be a regular schedule now, Sunday and Tuesday. So thanks a lot, and hope this helped.